Hello, this video will help you better understand your Skirkin figure 8.5 critical values of one-tail Z, the Z1 tail, and Skirkin 8.6 critical values of Z two-tails. These are on page 8.5 is on page 235, and the two tails is on page 236 of your Skirkin textbook. This is taken from your textbook. I like them together. I like to see them together when I think about this and when I explain it. So let's say the Z1 tail. That's like, for example, let's say we have a treatment, and we're like, hey, we have this treatment, it's study skills, and we really think that students' grades will improve if they use this treatment. Well, that would be a one tail. And let's say for a two tail is, we have this study skills, and we're not certain about this, if their treatment will get better or not get better. If their grades will go higher or lower when they engage in this treatment of study skills. So this is saying, we don't know which way it's going to go. It's an either or. And the one tail is like the directional. You say if they're going to get better. Or you could say they're going to get worse. The treatment's going to make them get lower scales. Either way, it's saying it's going to go in one direction. So for this one, we're looking at the probability or the p-value of 0.05, which in the book it has 0.05, but I like putting a 0 first. So let's look at that. Our Z critical for that would be 1.65 for a one tail. Our Z critical for a two tail would be Z equals negative 1.96 and Z equals 1.96. That's because that probability of 0.05, we have to split that between the two sides. So that number has to be divided in half. So the area equals 0.025. That means for here, let's say out of 100 people, because it's much easier to write 5 here, let's say out of 100 people, what this is saying is 5% or 5 people won't be affected by the treatment in the way that we're predicting. Where this one over here, since we have to divide that in half, well, okay, true, there's no such thing as 2.25 people, 2.5 of a person, that's a half. Of course, the drawing's interesting. For example, like, you gotta pretend my bell curves are even. That's the reason why I use statistical software, and that's probably why all of us do, because that way it's precise and also the stuff looks good. So here, that's what that has to be, is that 5%, or that has to be divided in between 2. That means that 95% of the individuals, or 95 out of 100, will fall within this range, and 95% or 95 out of 100 will fall within that range. That's what this is saying. So now we can work our way through it. It's a similar concept for the next one, where you have a probability of equals 0.01, your Z critical for this has to be 2.33. So for over here, the area, again, it has to be divided in half, because 0.005 plus 0.005 equals 0.01. For our probability equals 0.01. That's why, notice the Z here is Z equals, the critical for the two tail is Z equals negative 2.58 and Z equals positive 2.58. Notice the Z, look, is a bigger number than that Z, which is 2.33, and that one's a 2.58. The same as up here for the probability equals 0.05. Notice for a one tail, it's 1.65. But for the two tails, it has to be as high as negative 1.96 or 1.96. This is similar for the probability of 0.01, which a lot of medical fields and stuff, like for medicine, tell you one thing, if I'm taking medication, I'd want the p-value to be no lower than a 0.01 as far as it working the way it's supposed to. So the area probability for one tail is 0.01 for the tail, because it's just on one, which that has a Z crit of 3.09. And again, for the two tail, that 0.01 has to be divided in half. You have half of it on both sides. So the area equals 0.01 for this side and 0.005 for that side. When you add those together, 0.005 plus 0.005 equals 0.001, which is a probability or p-value equal to 0.001, which again, the z for these would be z equals negative 3.29 and z equals 3.29, which again, the z is, the number's smaller here and the z numbers are bigger here. So that's basically just a basic explanation as far as your z-critical values for your one-tail versus your two-tail in Skirkin. That's what this is.